All right, last homework of Unit 9. We are finding areas under curves. We're using Usubstitution. This is a definite integral, so that means we need to find the area by using the antiderivative. So we got to take the antiderivative. Part of the process, just like last class, is using Usubstitution. But what will be different from last class to this class is the use of changing these bases, which we didn't have to worry about the last class. But now that we are finding the change in things, we will. So I go through the process of doing Usubstitution. I'm going to leave these blank for now. Remember, we leave everything else the same. We take U, replace what it's equal to. We take dx and replace what it's equal to. Maybe I'll just show that step. Okay, but one extra step is you are going to change your bases from values on the x-axis to values on a u-axis. We're changing the axis in which we're looking at our function. And when we do that, we plug these x's into this equation, which ties x's to u's. So when I plug 0 into x cubed plus 1, I get 1. When I plug 2 into x cubed plus 1, I get 9. Okay, so that would be a successful changing of bases so that I have now u's being used instead of x's. The process of Usubstitution still follows, where we will simplify. I'll rewrite, and then I don't forget the most important step, which is taking the antiderivative. Get 1/9 u cubed plus c. I won't need the c in this case because I'll find the change between 1 and 9. Or, if I wanted to, I could have gone back to x's. 1/9, that'd be x cubed plus 1 cubed plus c. Don't need it because I'm doing it from 0 to 2. What you'll find is if you plug 0 and 2 in, it's the same as plugging 1 and 9 in here. So 0 and 2 plugged in here would give you 9 and 1. So regardless of which way you do it, I expect you to be able to change your bases. I'd get 9 cubed times 1/9, so that'd end up being 9 squared, which is 81, minus 1/9. I'm just going to leave that. Okay, next one, same deal. U is x squared. Du is 2x dx. Remember, u is typically the inside of the composition. The composition is e to the power. The inside of the composition is the power. Sub in u, sub 4 dx. This turns into x e to the u, 1 over 2x du. Changing my bases of 2 and 3, which are x's, using u equals x squared, that turns into 4 and 9. Cancel the x's. Maybe I'll rewrite this. 4 and 9, 1/2 e to the u du. Antiderivative, 1/2 e to the u. So I did take the antiderivative here. Just remember, like I took the antiderivative to get 1/9 u cubed. I took the antiderivative, but it just so happens the antiderivative of e to the u is e to the u. I got a plus c. I don't need it. I can find the change in this between 4 and 9. Or I could go back to x's. 1/2 e to the x squared plus c from 2 to 3. Regardless, we'd get the same answer. 1/2 e to the 9th minus 1/2 e to the 4th. All right, same deal here. This would change into 7 and 8. This is x cubed root of u, 1 over 2x du. Everything else stays the same. Change the cubed root into u to the 1/3. X's cancel. I'll rewrite. I'll take the antiderivative, add 1, it's u to the 4/3, multiplied by the reciprocal, that's 3/4, so that's going to be 3/8 plus a c. From 7 to 8, we'll need the c because I'm finding the change. It's the same as 3/8 x squared plus 7 to the 4/3 plus c from 0 to 1. I'm not going to be able to do 7 to the 4/3. I can do 8 to the 4/3. But let's just pretend this is like free response. You can leave your answers if they're not easily simplified like this. I'll put this in the same. Either way you do it, you will get 3/8, 8 to the 4/3 minus 7 to the 4/3. 3/8. Okay. Yeah, we remember definite integrals. It's like velocity times time. It's equivalent to the change in position. If this is my velocity function, this is my position function. I find the change in position to find displacement. Both of them would represent displacement, and there are two different ways to do it. All right, let's see what's going on here. Inside of the composition, derivative. Change bases. This is 9. 16 plus 9 is 25. This is x. This is u to the 1/2. This is 1 over 2x du. X's cancel. I'll rewrite this so I can take the antiderivative. Probably best to change it into a negative power and use the power rule. It's not a -1. Any other power, you use the power rule except for -1. Take the antiderivative. That's u to the positive 1/2 times 2. The 2 and the 1/2 go away. That's nice. Plus a c. Don't need it. Change from 9 to 25. That's going to give us the same result as if I do x squared plus 9 to the 1/2 from 0 to 4. So I'm going to be able to simplify this. So I got the square root of 25, which is 5, minus the square root of 9, which is 3. So the answer is 2. All right. Write the equivalent definite integral using change of bases to produce an integral number f of u du equals to a number. Okay, so okay, our goal is to replace this 5x with a u. Now let's just go ahead and start by doing that and see what happens. So I get u equals 5x, so that's going to replace it with a u. But I go through the whole process. du is equal to 5 dx. dx is equal to 1/5 du. You actually don't need Usubstitution for this. This is an f of an ax plus b. Its antiderivative would be big F of 5x times 1/5. What it's just telling you is that you'll need this 1/5. So let's just go through everything. 3 f of u, dx is 1/5 du equals 6. Now I'm going to go ahead and change my bases. 1 to 2 will change into 5 and 10. So I have the number, and an f of u, but I have other stuff in my integral, and this is just confirming that we know what we're doing when we change bases. When we have constants inside an integral, we could pull out the constants as long as it's being multiplied. So I could pull out this 3/5 and then multiply both sides by 5/3. And the answer I'm looking for is this. 5 to 10, f of u du, that's all I want. And then over here, this is 30/3, which is 10. And that's my final answer. That is in the form of a number to a number, f of u du equals a number. Okay, so we got some more like that. So let's just kind of go through them. Set u equal to the inside of the composition. Take the derivative, solve for dx. Sub in, change your bases. This stays as 1, this changes to 4. This is 3x, this is f of u. This is 1 over 2x du. This is still 6. The x's will cancel. I'll have 1 to 4, 3 halves, f of u, du equals 6. I'll multiply both sides by 2/3. And I get 1 to 4, f of u du equals 4. Okay. Let's check this one out. Two minus 1 is 1. 2 minus 4 is negative 2. So it appears I'm going right to left. You could flip-flop it so it's left to right. It doesn't matter. Maybe we'll put both answers down.
I have some other questions to ask.
X cancel. 4 divided by negative 2, negative 2. So this is 1 to negative 2 of negative 2 f of u du equals 6. I'm going to divide by negative 2. And just like I said, maybe you want to write it as this. And then maybe you want to write it as that. Possibilities. Okay, a couple more, same deal. Hopefully the Usubstitution process is no longer cumbersome. It's just, oh, the bases don't change because it's x to the fourth. 0 to the fourth is 0, 1 to the fourth is 1. Hopefully we don't think of this as just like something different. We are plugging in 0 and 1 into u equals x to the fourth. Just so happens that these would be the u's. This is f of u. This is 1 over 4x cubed du. This equals 6. X cubes cancel. I'm left with 1/4. I'll multiply both sides by 4. I'll do this all in one step. Okay, inside of the composition would be the root x. Derivative would be 1/2 x to the negative 1/2. It's 1 over 2 root x, which means dx is 2 root x du. Plugging in 4 and 9 into u equals root x turns them into u's of 3 and 2. This is f of u. This is root x. This becomes 2 root x du. The root x's cancel. Divide both sides by 2. My answer would be 2 to 3 f of u du equals 3. One more. This is x to the negative first. I would write this as x to the negative first and use the power rule, negative 1 x to the negative second. That's the derivative. Some of us may probably need to practice derivatives of these different powers, including negative powers, making sure we're not taking the antiderivative, making sure we're not saying it's a log. This would be negative 1 over x squared dx, which means dx is negative x squared du. Plugging in 1 and 2 into u equals 1 over x, this turns into 1 1/2. This is f of u. This is x squared. This is negative x squared du. Oops, I forgot a dx there. Hopefully that doesn't trip us up. X squareds cancel. Divide both sides by a negative 1. All right, next, we got some division going on, okay? Now, we get here, and we'll talk about, like, what we should do. But for these, I'm telling you, hey, the numerator is a version of the derivative of the denominator. If you see some sort of u prime divided by u, we will be using Usubstitution, where u equals the denominator. This will turn into an integral of 2x over u and then 1 over 2x du. Okay, so like, let's go through the u step. That replaces that. Dx gets replaced by this. The 2x's will cancel. Now I have to take the antiderivative of 1 over u. What we will find, and we remember the antiderivative of u to the negative first, 1 over x, 1 over u, is log absolute. What we'll find if we ever have a situation like this, we'll end up with a log. I need a plus c because I'm not finding a change. I'm just finding the antiderivative. So log x squared plus 1 plus c would be my antiderivative. This is an x squared. This is an x cubed. When I take the derivative of this denominator, it's a version of the numerator. So I get oops, I take u equal to my denominator. This turns into 5x squared over u. This is negative 1 over 12x squared du. That's not nice, but it's okay. The x squareds will cancel. This turns into negative 5 over 12u. Now, there are two ways to take this antiderivative. What I would recommend, it's the easiest one, is to just pull out this constant and then take the antiderivative of 1 over u. Recall, if this was like something like negative 5 over 12u plus 1, I can't just pull out the constant. This antiderivative would be negative 5 log absolute the denominator, but then I would need to divide by 12 or multiply by the 1/12 because of the reciprocal of the coefficient of u. This has to have a this does have a coefficient. There's no way around it. You have to have this 12. Here, if you pull out the 5/12, you'll see that this is the answer. But you could have found the answer and it could have had a 12 inside here as long as it had a 12 outside. It's a little bit confusing. Don't let it confuse you. Just like if it's not an AX plus a B, if it's just an AX, you could just pull it out. Got 3 minus 4x cubed as u, so this is negative 5/12 log 3 minus 4x cubed. Let's see. All right. Now, the numerator is not a version of the derivative of the denominator. The numerator is a bigger degree than the denominator. The numerator is a bigger degree than the denominator. When we see this, we need to divide to simplify. I'm going to take x plus 2 and divide it into x squared minus x minus 5. Now, you could do this using long division or synthetic division. Now, with synthetic division, we end up taking like the root of this. The reason why we do this is to make sure we're adding instead of subtracting. It just helps with the process. And we'll see that we're going to get up the same answer. So like the 1 comes down. Why do we have a 1 that comes down? Well, because I will have a 1 times an x multiplied by this that goes the largest into my first terms. So I see 1x. This is x squared minus 2x. I subtract, well, it'll be like adding the opposite. Here, I'm multiplying, and I get this negative 2. Well, this cancels. This comes up. This will be a 1x. Something happened. What happened? X squared plus 2x. Oh, that should be a plus 2x, which means this turns into a negative, which is why this will be a negative 3. So you see that negative 2 is right here. You add these together, you get negative 3. I end up adding these together. If I add the opposite, and I get negative 3x. Bring down the 5. This will be a minus 3. You see the minus 3 there because x times negative 3 is negative 3x. That'll cancel there. Negative 3 times 2 is negative 6. I'll subtract the 2. That's the same as adding the opposite. This turns into a remainder of 1. Well, multiply, you see this turns into a positive 6. Add them together, turns into a remainder of 1. Okay, so what does this tell me? That this integral could be rewritten as x minus 3 plus my remainder x plus 2's. How does the remainder, how do you remember the remainder? Remember, like, if you divide, 4 into 53. 4 goes into 5 once. I got 4, brings that down. 4 goes into 13 3 times. I'll have a remainder of 1. Well, 13 and a fourth. So like 13 times 4 gives us 52. Add another fourth, and that would end up being 53. 53 divided by 4 would be 13.25. So this is reminding us of like long division and how to deal with remainders. So 53 divided by 4. Let's see, 13 and 1/4. 13.25. This is x minus 3 and 1 x plus 2th. This is the same thing. Now remember, when you get synthetic, this is the remainder. This would be the number. This would be the x's. I'm going to go from right to left. Remainder number x is x squared is x cubes. So now I can take the antiderivative of this. This is 1/2 x squared. This is minus 3x. This would be plus log absolute x plus 2. Let's try this one out. You can either do long division or synthetic division. So we bring the 6 down. Why do I need a 6? Well, x minus 2 going into 6x squared, I need a 6x. This is 6x squared. This would be minus 12x. Subtracting those is the same as adding the opposite. Adding the opposite, this ends up being 8x's. Well, 2 times 6, 12. There's my 12. 12 plus negative 4, that ends up being 8. Bring down the 25. I'll need a 8. 8 times x minus 2 is 8x minus 16. Subtract, that's the same as adding the opposite. So 25 minus 16, that's going to be minus 9. 2 times 8, 16. There's my minus 9. Okay, so there's my remainder. These are my numbers. These are my x's. So this would be rewritten as 6x plus 8 minus 9x minus 2's. The antiderivative of this would be 3x squared plus 8x minus 9 log absolute x minus 2 plus a c. Okay? All right, our turn. Evaluate the indefinite or definite integral. Determine whether we should simplify. Treat as u prime over, treat as f of a x plus b, or treat as u prime over u, or long divide. Looks like I have 6, so I'm probably going to get one of each, maybe a couple of some others. First one, I could use u substitution. You could say that this is u prime over u, but I'm going to treat it as a f of a x plus b, where its antiderivative would be f of big F of a x plus b times 1 over a. This antiderivative, log absolute 4 minus 5x times negative 1/5. So that's an easy one. It's an indefinite integral. I need a c because I'm not subtracting anything. This one, we might be thinking long divide, and that's actually kind of what we're doing. But rather than thinking long divide, just simplify. Divide both of these terms by x. This turns into x plus 1. The antiderivatives would be 1/2 x squared plus x plus c. Don't forget the plus c. Third one, I see x, 4 minus x squared. I see u prime and u. I'm going to use u substitution here, where u is equal to the denominator. I'm going to go through the whole process of changing my bases. So 4 minus 1 is 3. 4 minus, this has happened before. 4 minus, that's negative 1 squared. This will be 3. Huh. Boom. Well, watch. I'll show you once we graph this. Probably good just to be able to take the antiderivative just in case. The antiderivative of this would be negative 1/2 log absolute u plus a c. I'd have to find the change in this between 3 and 3. We know this is going to be 0. I know that's 0. Watch, if you graph this x over 4 minus x squared, it's going to be what we consider an even function where it's symmetrical. And if I'm going from negative 1 to 1, sorry, it's an odd function. So if I'm going from negative 1 to 1, we can see the area from negative 1 to 0 is opposite of the area from 0 to 1 because this is underneath the x-axis. This is above the x-axis. Second calc, watch, I can find the integral from negative 1 to 1. And they say it's 0. There's no area. The accumulation is 0. All right, that's cool. This one I see x squared minus 2x plus 3 and x plus 1. This is a bigger degree than this. I'm thinking divide. I'm going to use synthetic division. I think it is probably a little bit quicker. Most of the ones you'll have to do, or all the ones that I've seen on the AP test and AP practice problems, are just dividing using synthetically. You just got to remember the process. Make this an opposite of that. It's just to ensure that we add instead of subtract. So negative 1 times 1 is negative 1. Add these two, that's negative 3. Multiply, this is 3. Add, this is 6. So a remainder of 6. Let's think, x squared minus 2x plus 3 is x. No, that can't be factored. Okay, so that's my remainder. So this simplifies. I'm not changing bases, so 0, 1 stays into, you know, this is remainder, this is our number, this is our x's. So this is x minus 3x, sorry, x minus 3 plus 6x plus firsts. The antiderivative of this would be 1/2 x squared minus 3x plus 6 log absolute x plus 1. Finding the change in this from 0 to 1, so I don't need the c. I have 1/2 minus 3 plus 6 log 2 minus the quantity of 6 log 1. 6 log 1 is 0. So since that's just 0, this is my answer, which is like negative 5/2 plus 6 log 2. Two more. Man, it's just an x. Divide. Just divide. Don't change bases. Don't do anything crazy. This turns into x minus 1 over x. The antiderivative would be 1/2 x squared minus log x plus a c. Don't need it because I'm finding the change from 1 and e. This is 1/2 e squared minus the log of e, which is 1, minus 1/2 minus the log of 1. We need to remember the log of 1 is 0. So this is 1/2 e squared. Log of e is 1 minus 1/2. That is 1/2 e squared minus 3/2. Last one. Tricky. You see the numerator? The degree is bigger than the denominator. I would divide. Now when I divide, since it's not just an x plus, I would actually use long division. I'd have 6x. This is 12x squared plus 6x. This is negative 6x. So this would be minus 3. That's minus 6x. This is plus a 0. Minus 3. Add the opposite. That turns into a remainder of 3. So I actually would write this as 6x minus 3 plus 3, 2x plus firsts. Find the antiderivative of that. This will be a little bit funky. Watch. This is x squared. This is 3x squared minus 3x plus. This antiderivative, 3 log 2x plus 1, I need a 1/2. Why? Because this is a coefficient of x. This is an f of ax plus b. From 0 to 1, I got 3 minus 3, which is 0. So I have 3/2 log 3 minus 0 minus 0. That's gone. Then I have 3/2 log 1. Log of 1 is 0. So my answer is 3/2 log 3. Just so I can feel good about myself. Let's check. Math 9, 0 to 1, 12x squared divided by 2x plus 1. I get some decimal, hopefully. I think that's 3/2 log 3. Okay, we win. This one's a little bit tricky. It's a little bit probably above expectations for you guys. But just shows you maybe you do need to know long division, not just synthetic division. So synthetic is a nice shortcut. Long division will always work. All right, that's it. That's it. We got a test coming up Monday, Tuesday next week. Exciting.